Hello everyone. So today is day 14 of the DSA challenge that we took, and the question that we're going to solve today is power of x comma n, right? So this is the question. Although it's a medium type question, the main motive of this question is to basically understand what binary exponentiation is, right? We'll get to it. Yesterday I claimed that this question is going to be solved using binary search, though it's not entirely true, but the logic is kind of going to be the same. Basically, the time complexity and everything is going to be the same. Great. Now what I want you to do is understand this question with a very brute force thing, right? We'll start from the brute force again. The question says that implement power x comma n, which calculate x raised to the power n, right? That is x power n. So this is the question, right? Uh, Power x comma n, right? Which is nothing but x to the power n, where n can be from minus 2 to the power 31 till equal, obviously, 2 to the power 31 minus 1. So it can be a negative power as, right? Is there any the thing given? Yes, there is given that x can be, so this x, right, the base that is given to us, it can be decimal also, right? Okay. Okay. So if we think of the if you think of the brute force, right? What is the brute force that we can use, right? So let's just say we have to calculate 2 to the power 5, right? How can it be written? It can be written 2 dot 2 dot 2 dot 2. So 5 twos, right? You can obviously calculate, right? You can obviously calculate that you will start your loop, which will go from somewhere between from 1 and uh, I will be less than, or maybe it's not right. This will go till n, and you will just, if your this result is equal to 1.0 or whatever, since we are taking JavaScript as our language, so you don't need to, you know, uh, apply any any decimal or float value. It will always be considered as a number. So a decimal is also a number, but an integer is also a number. It doesn't really matter. Um, Okay, you will go here and you will say that hey, rest is equals to uh, rest into x, right? And when this is done, you will basically return the answer. Now this is valid only when n is a positive value, right? N is a positive value. Great. And obviously you can have a condition here that if x is the n, that is the power that is given to you, if that is equal to 0, if n is equal to 0, you can return a simple x, right? Because obviously, sorry, not x, you can return 1, because anything raised to the power 0 is nothing but 1, that you know. Great. But what if the value is a negative? Value is negative. You obviously know this, right? So if I say that 2 to the power minus 2 can be simply written as 2 to the power 2, 1, 1 divided by 2 to the power 2. So what if 2 to the power negative 2, it is nothing but 1 2 upon 1 power 4, which is nothing but 0.25, right? So if what you'll do is you will pass an absolute value. When you are here, you will simply say that hey, this should not run till n, it should run till max dot absolute, till the absolute power of n. And then when this loop is done, now you will check if the value is negative. If the value is negative, you will return simply 1 divided by result, right? Because that's what we did here. Correct. What is the time complexity for this loop? It is nothing but O to the power O n, that is linear, and space complexity is nothing because we did not use any extra. Great, great, great. Now let's consider one more example and then we'll move to the optimal solution. Great, right? the more optimal solution or the great approach, right? The better, the binary exponential creation approach. If I write 10 2 to the power 10, can it be written 2 to the power 5 into 2 to the power 5? Great. Can this be written as 2 into 2 to the power 4 into 2 into 2 to the power 4? You will say, hey, yes, it can be written. Okay. So I can say that way 2 to the power 4 can be written as 2 to the power 2 into 2 to the power 2. Okay. You will again write here 2 to the power 4, sorry, 2 to the power 2 and 2 to the power 2. This can be further boiled to 2 to the power 1 into 2 to the power 1. Great. Here also, and here also. Can you see what I'm trying to do? Okay, you can, right? So basically, I'm dividing my whole power. I'm dividing my whole power into two parts, into two separate parts. Part, great. So if 2 to the power 10 can be written as 2 to the power 5 into 2 to the power 5, and 2 to the power 5 can be written as 2 into 2 to the power 4. I mean, consider just this, right? If the value, sorry, if the power is even, what are you doing? You are simply saying that, hey, it can be written as nothing but x into x, right? X into x. I mean, obviously, the power n by 2 and power n by 2. And if power is nothing but odd, you can say that hey, x into x to the power n by 2 into x to the power n by 2. Great. Can you kind of relate it to we to us giving it a logarithmic time complexity? Didn't we do kind of same in merge sort and probably in binary search? Yes, we were dividing it by two, right? We were dividing it equally by two. We were dividing it by equally two parts, right? Okay, great. Can I call it binary? Now, what is binary? Binary is either zero or one. So what I'm saying, hey, it's either zero or it's one. It's either white or it's black. It's not gray, right? It cannot be any other color. It's either zero or it's either one or it's either black or it's either white. Hmm. Great. So now we have understood that we have to somewhere think in that manner, right? We are thinking in that manner. Great. Okay. Mm, what can be the time complexity? Let's understand. Let's understand. Okay. I'll write it somewhere here. Okay. Let's say that 2 to the power 10. When you were doing for O of n, you were multiplying it by 10 times. You were running a loop starting from 1 and going to 10. Okay. I can write it as 2 to the power 5 and 2 to the power 5. So 1, right? Okay. Okay, what if I call it 60, right? That would be much better. So 2 to the power 8 and 2 to the power 8. Great. Um, what I can write it as 2 to the power 4 into 2 power 4 into same thing. So that's 2, right? 2 dot 2, 2 to the power 2, 2 to the power 2, 2 to the power 2 dot, and this again copied here, right? Same thing. Great. So 3 result. 3. Again, this can be written as 2 into 2, right? What if I copy this and paste it one time for this, for this? What if I write for this? Same for this, and so on, right? And so on for all these things. So 4. Can this be further boiled? So 2 to the power 1. Can it be divided even further? 1 divided by 2. What is it? It is nothing but 2 to the power 0. If you take the floor value, obviously, and consider every time now we are only talk about floor until unless I don't need field value particular. Great. It can be written as 2 to the power 0, which will which will be nothing but 1, right? But again, you will have to, like I told you here, like I told you here, you will still have to multiply it by x. So what is x into 2 to the power 0 into 2 to the power 0? What is it? Can 2 to the power 1 be written as this? You will say yes, it can be written as, because this will be 1, this will be 1, and you will multiply by 2. Isn't that the same situation? Yes, it is, right? So we solved this 2 to the power 16 in just 4 steps. In just 4 steps. Okay. Now I can say that hey, 4 is nothing but 4 to the power 2 is nothing but 16. Great. So I've taken 4 steps, and my what is my n in the power is 16 that is given. Can I say that here 4 is nothing but log base 2 of 16? You will say yes, it can be written as. So what is the time complexity? It is nothing but O of log n. Great. Am I using any extra space? You will say no, you are not. You are just calculating. And by the way, it's multiplication 2 into 2, 2 into 2. It is all just O of 1, right? It is all just O of 1. Great. We now know that we have to use this logarithmic value. Great. Let's write a pseudocode for it, right? Let's write a pseudocode for it. Pseudo code. What is spelling mistake? Yeah, it's a spelling mistake. Okay. Let's have a result which is nothing but 1. 1.0 or 1, whatever it means. Since what do you call it? Mm, it's a float with the number value, so it doesn't really matter. You can take 1 or whatever, right? I will say that, hey, I will initialize something called power, which is nothing but power, which is nothing but the power that is given, that is n. So I'll say that math of absolute of n. Now, why am I taking this? Why am I taking this? I just want that I should calculate all the answers in the positive side, and then if my n is negative, I'll just divide it by 1, like I already told you above. Right? So I'll say that hey, let's run a loop while power is not equal to 0. Right? When power is not equal to 0. This I hope you all understand. If it is 0, you will simply return 1. That is here, that is already here. You will have to return your result somehow, right? Great. So what can I say? What can I say? I can I can have two types of power, either two types of positive power, either odd or even, right? So I'll first check if if my power if my power mod 2 is equal to 1, or I'll say just not equal to 0. Basically odd, right? Yes. Yeah. What I'll do, what did I tell you? That you just have to multiply it with x. So I'll say that hey, result will be nothing but result into x, and what I'll do is I will decrease my power by 1. Decrease my power by 1. Okay. Now if the power is 2 to the power 5, right? Is 2 to the power. Okay, what we'll do is we'll just, take the dry run later on. We'll move it for now. I'll just first of all explain you the code, and then we can probably move to the dry run. This is the else. Else. Where did it go? Yeah, here, right? Okay. Now if the power is even, I'll write even here, even power. What did I need to do? What did I need to do? I'll say that hey, just simply x into x into x, right? You multiply 2 into 2. Basically, if x is given as 2, the base is given as 2. And what you'll do is you will divide your power by 2. You will divide your power by 2, right? That's what we are doing. We are multiplying it and then we are dividing it by 2. We are dividing the power by 2. Great. Okay. Okay. So if now that I've come out of else loop, right? What if my else loop has done its work? Sorry, my while loop has done its work. Now what? Now I check that if n is lesser than 0, if it was a negative value that was given initially in the question, I'll say that hey, result, just simply do one thing. Just do one thing for me. Just get divided by 1. Is this what we require? Is this what we require? And at the end of the day, just return result, right? Let's try it. Let's first try it. Let's first try it. Great. So I am given a question called 2 to the power 10. No problem. Great. Okay. So I'll say my rest is now equal to 1. Okay. My power, which I'm taking as P right now, is nothing but 10 only. Absolute value of 10, that is 10 only. Great. Is my power equal to 0? No. Right? It is not equal to 0. Is power divided by 2 is an odd value? So sorry, divide by 2. I'm saying sorry. Is my power an odd value? You will say no, it's an even value. You will say that hey, what is my x? X is nothing but 2 right now because this is the base given. So I'll say that hey, x is equals to x into x. What is x into x? It is nothing but 4. Great. And power is divided by 2 now. It becomes 5. It becomes 5. Great. No problem. Mm, then I go up again. Is my 5 equal to 0? You will say no. Is it an odd value? You will say yes, it is an odd value. I'll say that a result is equal to result into x. Now, what is result into x? It is nothing but 4. 1 into 4, it becomes 4. And power is nothing but 4. It becomes 4. No problem. Again, I go back. Is power equal to 0? No. Is it an even value? Yes. So I'll come here. X is equal to x into x. So it becomes 16. 4 into 4, 16. And power gets divided by 2. Great. Again, not equal to 0. Is it an odd value? No, it's an even value. Value becomes 16 into 16. That is 256, I guess, right? 256. Great. And power gets divided by 2. 1. Great. Again, I'll go back. I'll go back. What is 2 to the power 10? Let's first. 2 to power. It's 1024. Okay. Okay. No problem. No problem. Is 1 equal to 0? No, it is not equal to 0. Right? Is it an even value? Yes, it is an even value. So we'll say that hey, rest what you do is you multiply 4 into 256. Now what is 4 into 256? Let's quickly understand that as well. All clear. 4 cross 256. What is it? Wow, this is nothing but 1024. Okay, okay, and power becomes 0 because it becomes minus 1. So power minus 1, it becomes 0. Is my power equal to 0? Yes, I break out of the loop. I break out of the loop. Was my n given as a negative value? You will say no, it wasn't given as a negative value. So simply just return. What will be I return? I will return 1024. Was that the required answer? Yes, it was the required answer. Great, great, great. Let's try to get this code. What did I need? I need result, which is nothing but 1, right? I needed power, which was nothing but math dot absolute of n, right? I'll say that hey, while power That is, if power greater than zero, I mean, it can be written as this: if power is true, so zero is false and one is true, right? Um, Basically, not zero is false. If power is equal to zero, this what does this imply? It implies that power is equal to zero or not. Great. So I'll say that, hey, if my power mod 2 equal to 0, basically if it's an even value, right? What did we need to do? If it's an even value, we said that, hey, x is equal to x into x, and power is equal to power divided by 2, right? And if it's an odd value, we said that, hey, result, you just get multiplied with my x, and power is equal to power minus 1. Didn't we use this only? It was the same situation. Earlier I wrote odd value first and then even value, and now I'm writing this only. No problem. Now I come out to the else loop. If my n is less than 0, result becomes result 1 divided by result, and I simply return my result. Right? Let's try to run. Result is not defined. Why is it not defined? Because this is this. I'll say that, hey, you become result because I don't want to change all my rest. Great. Gives you this value. Submit. This is accepted. Great. I will write one more code. Now I will do one more thing. I will do one more thing. Though it's very difficult to explain you on Excalibur, but I'll still try to do it because I I wanted to write this code first. I wanted to write this code first. This will be a recursive solution. This will be a recursive solution. So let's remove this. Confirm. Great. Let's write one more function that is called function calculate absolute apps power, right? It will take us the same thing. Great. I will write my base case later on, right? I will write my base case later on. No problem. I will write my base case later on. So what can I say? That, hey, net result can be equal to. I will explain to you. Don't worry. I will explain to you. Can it be? What are we doing? What are we doing here? Just simply dividing it by two. We are just simply dividing our exponent power by two. So I'll say that, hey, x, and you will have to take math or floor of it, right? Right? This is what we are trying to do. This is what we are trying to do. Okay. I'll say that here, this is equals to this into this. Basically, I am multiplying it. Now, why am I multiplying it? You knew already from here that this 2 to the power 8 can be written into 2 times. So to achieve 2 to the power 16, yes, great, great, no problem. If I'll say, if my n mod 2 is equal to 0, what will I do? What will I do? I will simply, basically, uh, okay, if my power is odd, what will I do? Mm, let's see. Can I say that I will, mm, okay, let's try to think about it. So yeah, uh, can I remove this floating panel? Yes, I can. So if my n is equal to, if my n is divisible by 2, what will I return? I will return, so let's just not write this. Let's write this. Return n mod 2 equal to 0, basically. If it is an odd value, if it is an even value, then I'll simply return my result or rest else I will return x into result. Okay, why am I saying this? Uh, did we, I think for 2 to the power, yes. For here, when we were writing 2 to the power 5, weren't we calculating it by x? Weren't we calculating if this was my recursive thing? I was calculating it with x, right? I was calculating it with x. So that is what I'm trying to do here. Great. What I'll do is, I'll say that, hey, okay, I need to write my base case value. Now, what are my base cases? I will say that, hey, if my x is equal to 0, what will I return? If my x is equal to 0, I will return 0 only. If my base is 0, then I will obviously return 0. If my n is 0, what will I return? I will return 1. Great. What if my n is equal to 1? Although it will be calculated from here only, but maybe I don't even need it. Great. Can I remove this line? Can I remove this line and write it here only? X into x? Yes, I can. Yes, I can. Okay. Now what should I pass it here? I will say that hey, just copy it, right? And what you need to do is, what do you need to do? What do you need to do? You will say that hey, okay, okay. I'll just say, I told you something. I told you something, right? I told you that you need to pass the absolute value, right? So I'll say let result is nothing but of this map dot absolute of n, right? If my n is lesser than 0, or maybe I can say that hey, return n lesser than 0, 1 divided by result, else return result. Can this be written? Yes, let's try to run this code. Accepted. Great. Let's try to submit. Great. Accepted. Accepted. Do you want me to? Okay, let's do one thing. We'll just simply take a simple base case for it. A simple case for it. Can we say that, okay, what if I write down my code here, right? What if I write down my code here and my x is given to me as 2, and let's just say if my n is given to me as 4, right? I'll take a very easy example just to explain it because this code is very explanative, very much explanative. I will pass my absolute value to n of n, right? So here, is my x equal to 0? You will say no. Is my n equal to 0? You will say no. Right? What will my result be? Result will be calculate this recursive of x into x, that is 4, comma. You will say that, hey, I will first what I'll do is I'll just write down here. Great. What was my x now? X was x into it, that is 4. And n, and what is my power? Power is divided by 2. So it becomes 2. Great. Uh, then what will it do? It will, okay, let me do something because this will, should I remove this? I just have to remove this and this becomes here. Great. Now I can work with it. Now I can work with it. Great. Is my x, why? Let me first, sorry for the inconvenience. Let me just copy it. Copy it. Great. Can my 4 be? Can my is my x zero? No. Is my n zero? No. Again, I will do one thing. I will do one thing. I'll just, what I'll do is I will again let s is equals to nothing but, when x is equals to x into x. What is x into x? Is just 16. And what is my n? N is divided by 2, which is going to be 1. Is my x 0? No. Is my n 0? No. Again, calculate this. What should I calculate? I will calculate this. Where? Where my 16? Where my x is what? 16 into 16, that is 256. And n is what? N is n divided by 2, that is floor of it, so it's 0. Is my x 0? No. Is my n 0? Yes. So I will return 1. I will return 1. This returns, what does it return? It returns 1. Is return, what do I need to return here? It returns 1. Great. So if I move here, is is my n mod 2? You will, is my n, what is here? N is 1, right? What is n here? N is 1. It is an odd value, right? So I will multiply x into result. What is my x into result? X is nothing but 16 into x. Basically, x into result. Result is 1, so 16. This returns, this returns back 16, right? Is my, is my result, that is, what is it? It is nothing but, um is my n odd? No, it is not. So I will simply return this, that is only 16 only. Great, great. So what is my, let me come here. So if my x was 2 and my n was 4 here, right? This was my n and x, right? So what did I return from here? I returned 16 only. Now this holds a value of 16. Great, right? Is my power even? Yes, it is. So what I'll return? I will return to it 16. I will return to it 16. Is my n lesser than 0? No. So I will just simply return 16, and this is what my answer is. What is 2 to the power 4? It is nothing but 16 only. Great, great. This is what we wrote here. I hope you understood both the recursive and also the time complexity here also. How many um, steps did we use? How many steps did we use? So one for one this, two, three, and four, right? So 16 was our answer, and divide by four is nothing but four, which is nothing but log of four, right? 16 can be written as log of four, and this is what is O of log base 2. Sorry, log base 2 of ym. Log base 2 of n. So this is the time complexity. You can say that, hey, it took n for, this can be said as recursive stack, right? O of n for recursive stack, though it's a temporary space, that but you can tell to your, um, basically your interview that, hey, I took a recursive stack of O of n, but if you want to consider it, then space complexity is O of n, or else I did not use any extra space. He will be very much happy. We have successfully done our question. So let's write here. You need calculate. You need bin, uh, binary exponential, right? Binary exponential power, or binary exponential, the same. You simply have to divide the power by 2 and do the math, right? Simply, let's try to save it, and Let's mark it as done. Great. We are done with this question. I hope you understood both the recursive and as well as the iterative approach. And this is very easy, but you still have to do, make it on pen and paper, and you can obviously write every recursion stack for recursion, and iterative is you can do all the dry runs. Basically, dry run is the key here. So thank you so much for joining in. I'll see you tomorrow with this question called majority element that is greater than n by 2 times. Thank you so much for joining in. I'll see you tomorrow. Bye bye.